நான் பேசுங்க சார் இருக்காரு பேசுங்க. இது நான் நிக்கிறேன் இருக்காரு சார். அதுதான்
Start. Hello.
Yes, sir. Sir. Sir, I have joined in 2 devices, sir.
Okay, no problem. My voice going no correctly?
Yes, sir. Yes.
Okay. Tell your doubts and all.
Sir, first doubt is,
Tell.
sir, here, can you look at the screen, sir?
I can see.
Yeah, yes, sir. Sir, here H8 I have written, but it is R0, R1, 180, and H and D. These are the subgroups we have written. But in that R180, 90 is missing, no, sir.
That is
That is also one subgroup only, no? So,
listen, 4 or in D4, 4 order, how many subgroups will be there?
yes, sir.
So first subgroups is your by rotation R0, R90, R180, R270. Okay.
Yes, sir. Yes, sir. Yes, sir.
These two coming R0, R180 HV and R0, R180 TT dash, both are coming by center of H and center of D. Sorry, centralizer. Centralizer of D and centralizer of H.
Yes, sir. R0 and R180.
Yes, there R90
Yeah, yes,
if you will put won't come correctly.
Sir, can you say once again, sir?
You go back in your notes.
Sir.
You see in D4 subgroups where I gave first subgroups by D order elements.
Subgroups by
in
D order
D4, in D4,
yes,
1 order element existing, 2 order element existing,
yes,
4 order element existing.
Yes, sir.
So
correct, sir.
by 1 order, identity will be the subgroup R0. Two
Yes, sir,
order,
correct, sir.
two order in D4, 5 elements are there.
Yes, sir, yes, sir.
So 5 subgroups will be there. R0, R180, R0 H, R0 V, R0 D, R0 D dash.
Yes, sir, correct, sir.
And 4 order elements will be 2. R90, R270. So by 4
sir.
order, how many subgroups will exist? So R0 and 4 order element will come R90, R270. But only 3 elements coming R0, R90, R270. Another 1 element we want. So who will come?
Yes,
2 order elements will come.
yes, sir.
And 2 order we have 5 elements. Then who will come?
Yes, sir.
So I put the time R180 also, H,
Yes, sir.
4 order subgroup in D4. R0 will be there. R90 will be there. And R270 will be there.
Yes, sir.
1 minute. Who is this? Galaxy M31 Prabhakaran. More different person coming. I also don't know. So R0, R90, R270. 2 or 4 order elements. Santosh, you
Yes,
see,
sir.
you are seeing board seeing, no?
Yes, sir, yes, sir. Seeing, sir.
Okay. R90 and R270 is a 4 order element.
Yes, sir, correct,
R90
sir.
is the identity element. But
Yes,
we
sir,
want
correct,
4 order subgroup means 4 elements inside we want. So who will
yes.
be the third elements? So 4 order subgroup means 2 order elements only possibility for coming
sir.
inside. So we have 4 order element. Sorry, 2 order element.
2
5.
order elements.
R180, H, V, D, D dash means 4 order subgroups, 4 type of possibility. Correct.
Yes, sir.
But if you will put this place H, then closure law won't satisfy. V, if you will put closure law won't satisfy. D, if you will put closure law won't satisfy. D dash, if you will put closure law won't satisfy. Only R180 you will put, then closure law satisfaction will come. So this all 2 order element you can't put this place. If these 2 order elements you are putting and this is giving satisfying group property, then 4 order subgroups will be 5 types of subgroups. But no,
Okay.
these are not possible. These are not closure law satisfying. You can see your Kelly table also. R90H will be D and HR90 will be D dash. R90H D means here D is not available. So closure law does not satisfy. Group property won't satisfy. Okay. So these are not possible.
Yes,
So
sir.
by 4 order element, only one subgroup is there. 4 order element. I told no that how to find subgroups.
Yes, sir.
First, every group has 2 subgroups minimum. Identity and group itself. Next method by D order element. Next method center and centralizer. So by 4 order elements, we are getting only these subgroups. When you will find center of, you see your notes, Santosh, after center and centralizer, again I find D4 element centralizer.
Yes, sir. Yes, sir.
In this centralizer of H will be R0, R180,
Yes, sir.
and H and V. This is centralizer of V also. And centralizer of D will be R0, R180, D, D dash. And this is centralizer of D dash also.
Yes, sir. Yes, sir.
So these are 4 order subgroups extra you are getting by centralizer.
Yes, sir.
Here R90 not possible. R0 and R0 and R180 are center of group element. So in every centralizer, these 2 elements must will be there.
Yes, sir. Yes, sir.
How here R90 will come? R90 can't give. R90 is the proper rotation, collection of rotation will come.
Okay. So it cannot be considered as subgroup itself, right, sir? When R90 comes.
No,
Because,
closure law won't
closure
satisfy.
law not satisfying. So
Yeah.
it is not a subgroup itself.
Yeah, suppose if you will put here R90, then R90H is what? D. D here have. So
Yes,
closure
sir,
law
yes,
does
sir.
not satisfy. So
Understood, sir.
R90, how you can't put? Yeah, must. R0 and R180 is the center of group. So centralizer you will find, then every places will be there, no? Because that both are commutative with every element.
Yes, sir, yes, sir. Understood, sir.
Next doubts.
Yes, sir. Next. Sir, next one.
Hmm.
Sir, this one, sir, U50 into A5 multiplication, how to find out? There is a doubt, sir. That U I can that prime
U50
factorization I can do.
U50 cross A5.
For A5.
This is
Yes, sir. Yes.
this is external direct product. No, U50 you find by UN method.
Yes, sir.
U50 will be prime factorization 5 into 10. No, 5 square into
yes,
2.
Sir. 2 into yes,
Prime
sir, 5
factorization.
square. Yes, sir,
So
yes,
this will be the U5 square into U of 2. U of P to the power R formula. Z P to the
Yes,
power
sir.
R minus P to the power R minus 1. And U of
Yes,
P
sir.
is Z1. ZP minus 1. So 25 minus 5 is 20. So Z20 cross Z1 and Z20 cross Z1 isomorphic with Z20. So
Yes, sir.
U50 is called a Z20. So from here you can write Z20 cross A5. Finish. Here
So,
after which
so A5 we can't do anything, right, sir?
no A5 we can't do
As it is
anything.
only. That's the confusion, sir. This U I know, sir. Unit group how to split I know.
Yeah, after that you have to solve which order element existing in both like that.
Yes, sir. Yes, sir. So next I'll copy, sir, once again. Okay, sir. Next. So, sir, similarly, for S4 also, U10 into
Yeah,
S4 also.
every U
S4
of
will
n.
keep as it is, sir.
Yeah. S4 same will be there. UN, actually U50 and all we can't find. No more elements are there. So
Yes,
you
sir,
change in whatever short concept I gave. That isomorphic groups you change. From there you go after that.
Okay, sir. So, yes, D4 and all will be as it is only.
Yeah,
right,
same
sir?
only. D4 what we will
Yeah.
can't change anything.
Yeah. Yes, sir. Yes, sir. I thought something we can reduce further, something like that. Right? I thought
No.
only. Yes, sir. Then I'll go for the next. Sir, able to see the screen, sir. Yes, sir. Here, why it is cyclic? Okay. Why this is cyclic, sir?
Why this is cyclic? There only 3 elements are there. 0 plus
yes,
H,
sir.
1 plus H, 2 plus H.
Yeah, yes, sir.
Okay. So, and operation will be same addition modulo 6 only.
Yes, sir.
G by H, any quotient group, binary operation is G binary operation, G star. So Z6 by any normal subgroups, that binary operation also addition modulo 6 only.
Yes, sir. It's sir. Addition model.
Okay. So Z6 by 0, 3 quotient group, 3 distinct left coset is there. 0 plus H, 1 plus H, 2 plus H. So generate, if you want a first I will tell you that group order is 3. Prime order, and prime order group is always cyclic. So direct you can write that Z6 by 0, 3 is the cyclic group isomorphic with Z3. And if you want from here generator, you do 1 plus H will be the generator. Just 1 plus H power 1, power 2, power 3 you do. 1 plus H, power 1 will be 1 plus H. 1 plus H, power 2 means 2 time operation. So here will come 2 plus H. Power whole cube if you will do, then 3 time addition. 3 time addition means 3 plus H. So like that generating, so 1 plus H is the generator.
Yes, sir. Yes, sir. Sir, once again, sir. Sir, then 1 plus 3 we are doing addition modulo 3 we are putting, no, sir, there.
No, addition modulo 6 will come by 3. Z6 group operation is addition modulo 6. This is your finding from normal subgroup of Z6, no? So Z6 by any type of normal subgroup, their operation also same only.
Yes, sir. Yes, sir. But okay.
Modulo 3 concept you can choose from Z3. You can write this is isomorphic with Z3. This Z6 by 0, 3 you choose. This is isomorphic with Z3 you can choose. And from here modulo 3 you can use for here.
Yeah, yes, sir. Yes, sir.
And here means this place don't apply. Here 3 have, so 3 plus H, 0 plus H, not like that. Next, when you will do 1 plus H power whole cube, then 4 plus H will come. 4 plus H plus modulo 3 you will apply means 1 plus H will come.
Yes, sir. But
after
the question is,
this, modulo 3 here don't apply. After will increase, there you can modulo 3 just help taking. That is not a correct concept. I can't modulo 3, I can't use here. If modulo 3 direct I will use here means this is 0. 0 plus H.
Yes,
but
sir.
That is
a
wrong.
confusion, sir.
No, don't use them. Confusing means don't use. Just I am telling for your clearance. Otherwise, you find what is the 1 plus H power whole 4. This will come 4 plus H. And
yes,
4 plus H and your 1 plus H both will be same. If you will tell, sir, how same, then you find your left coset. Both set will be same.
Oh, yes, sir. Yes, sir.
So we have no time this much now. So
yes,
by that I am telling isomorphic group modulo 3, if you will apply after this power 4, power 5, power 6, modulo 3, if you will apply, this 3 only will repetition.
Okay.
For that, just help. Otherwise,
yes,
you have to go by set. Both set are same.
Yes, sir. I was applying with the set only, but why we are not getting? I was thinking. Yes, sir. Yes, sir. Now only understood. So I'll just note down.
Next. Clear all doubts today itself.
Yes, sir.
Sir, is this for Saturday class also, sir?
Who is this? KMS
Satish,
writing?
sir.
Satish. Oh, Satish. Which Satish? New batch admission taken, Satish.
Yes, sir.
Oh, okay. I confused KMS also. KMS Satish, right? At least I thought any. Okay, what Satish? What you told?
Sir, for us, you told the class will begin on Saturday, right, sir? 8th.
Yeah.
But all of a sudden, you started today the class.
No. Just I put every groups. Anybody any doubts for that? Every groups I put. No. Today not class is starting. This is you say link writing doubt class like that.
Oh, okay, okay, sir. Okay.
Just I put every group forward. So your group maybe also came.
Sir,
Okay, sir.
sir, again, slightly it is confusing. Can you just clear this doubt alone, sir?
Tell me.
Sir, if this is cyclic mean, right? One element should generate every element.
Yeah.
Correct, sir. Yes, sir.
1 plus H,
1
plus H, and 1 plus H is the generator.
Yeah, yes, sir. 1 plus H is the generator. This is coming like identity, right?
Our
this is identity.
1 minute. Z3 is the cyclic group. Power whole cube. 1 minute here. What I got? What you wrote? Z6 by 0, 3, 0 plus H, 1 plus H, 2 plus H. That is 2 plus H writing, no? Yeah, 2 plus
Yes,
H
sir.
also
2
will be
plus
the generator.
Yes, sir.
Then okay, correct. Have here 0 plus H, here 3 plus H will be the equal with 0 plus H. Correct only.
Yeah, 0 plus H will be equal to 3 plus H. Yes, sir.
Yeah.
That means is this identity, sir, then? Right?
Yeah, 0 plus H is the identity.
Sir,
every G
can you
by
tell
H.
Me? Yeah, yes, sir. Can you tell me how we can add these?
Here this will be the equal with 0 plus H. Means both sets are same.
Yes, sir.
Every group, every type of quotient group G by H, H always will be the identity element. EH, HE or H. And here 1 plus H and 2 plus H both are inverse to each other. Additive inverse. So 2 plus H also will be the generator.
Yes, sir. So yes, sir. Yes, sir.
2 plus H
one,
power 1, 2 plus H, 2 plus H power 2 will be 4 plus H. Then 4 plus H will be 1 plus H. 2 plus H power whole cube will be 6 plus H. Then that will be the 0 plus H.
Sir, 1 second, sir. Sir, here 2 plus H, right, sir? Power 2 if you put, then it becomes what, sir?
4
it will
plus
become
H.
4 plus H. Correct, sir.
Yeah.
But that 4 we are again addition modulo 3 we are doing, right, sir? And modulo 3 we are doing.
Yeah,
and
direct when you are going direct modulo 3 every places you apply.
Yes, sir. Yes, sir. Modulo 3 why we have to apply, sir? It is plus 6 only, no. Modulo 6 only, no here.
Listen, I told hey Bhagwan, listen first. I told just now, we are taking help from Z3.
Yes, sir.
I am not. You are correct that why don't apply. I am not telling you apply.
Yes, sir. Can you apply and show that method?
No, if you will tell that 4 plus H, how I am writing equal with 1 plus H? This will be the equal with 1 plus H. How? So you find first your every set element. What is the 0 plus H set? What is the 1 plus H set? What is the 2 plus H set? After that, you see, when you will find by this normal subgroups 0, 3, left coset, right coset will be equal, and total number of distinct left coset will be 3. 0 plus H, 1 plus H, 2 plus H. And from 3 plus H, repetition will come.
Yes, sir. Yes,
3 plus H equal to will come 0 plus H, 4 plus H equal to will come 1 plus H, 5 plus H equal to will come 2 plus H, again 6 plus H equal to will come 0 plus H. So, but on exam hall, we have no time. So you can take help from whatever isomorphic group have. Here modulo 3 we are using. That modulo 3 direct you divide this portion. I am not dividing inside element. 4 plus H inside element modulo 3 I can't apply. But this outside element I can apply. Why? Because outside element 0, 1, 2, 0, 1, 2, 0, 1, 2 repetitions are there. In that modulo 3 I can apply.
Understood, sir.
Suppose Z by NZ writing, generalization. Z by NZ is here. So this is isomorphic with Zn. So Z by NZ inside elements modulo n, no need to apply. But for this, what elements will come? 0 plus NZ, 1 plus NZ, dot, 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 and minus 1 plus NZ. So when you will solve 1 plus NZ and suppose 2 plus NZ, then 3 plus NZ. So that 3 plus modulo n and all can apply.
Yes, sir. Yes, sir. Understood, sir. Now understood.
Just saving time. We are getting hints, means we will use.
Yes, sir.
Writing anything?
No, sir. No, sir. Finish it, sir.
Okay. This Z by NZ. Yeah, isomorphic with cyclic group Zn. Yes, any type of cyclic group also can ask. Suppose I will write, they will ask Z by NZ is isomorphic with what? First option, Zn. Second option, Cn. Third option, another any cyclic group. Suppose here fixing type anything giving, then here another cyclic group will be, suppose I am giving Tn now for a cyclic group of order n. So Z by NZ is a cyclic group isomorphic with Zn, I know. Cn group I gave, this is the collection of rotation of Dn. Only collection of rotation. This is a cyclic group. So this is isomorphic with Cn also you can write. And any cyclic group, any cyclic group, another cyclic group, that nth root of unity, that also cyclic group. Either any operation, that also correct. This is not a cyclic, so this is a wrong. No, isomorphic when have, then why operation will be same? Maybe same, may not be same. This is a cyclic group of order n. If any type of cyclic group of order n you are getting, you can tell isomorphic with Z by NZ. And every cyclic group of order n is isomorphic with Zn. So every means any type, no? If this is isomorphic with Zn and this is isomorphic with Cn, so this is isomorphic with Cn. Next.
Sir. Can you see the screen, sir? Sir, here order of R90 of
Center of D4.
Center of D4. Two we have written, sir.
Yes.
Can I know that over there I get confusion, sir.
R90 center of D4, power 1 is R90 center of D4, correct?
Yes, sir.
Power 2.
That power 2, how we are doing it, sir?
First you learn, you see definition, and you learn from there that how to operate quotient group elements.
Yes, sir. Yes, sir.
Definition will correctly read. A star H and B star H, two elements of quotient group. Then A star H star B star H. How to operate both? So will come A star B star H. Like that. So if R90 center of D4 is there, power whole 2 doing means 2-time operation. So
yes,
R90 what will come? R180 only will come, no?
Yeah, yes, sir. R180.
So R180 center of D4 is what? What is the value of this? Center of D4 is your R0 and R180. Hereafter, if you will operate R180, R0 will be R180, and R180 will be R360. Will be R0.
Okay.
So again, you are getting same R0, R180 only, no? And what is this?
Yes,
This is center of D4 only. And this is only R0 center of D4. Identity element.
Yeah, yes, sir. Yes, sir.
And
that
this,
that actually that calculation is not here, sir. I
oh
don't
no,
know.
I am doing in class always full
Yes, sir,
calculating.
yes,
You are
sir.
not writing maybe.
Yeah, yes, sir. Maybe what happened, I don't know. I'll write, sir, once again, sir.
So order of R90 center of D4 is a 2-order element. In D4,
Yes, sir,
R90 is a 4-order element. Power 4 identity coming. But this is quotient group element. D4 by
Yes, sir,
center
yes.
of D4. So this is a 2-order element.
Yes, sir. Up to R180, no, sir. Up to that, I was able to understand. R90 plus R90, we are doing yes, sir. Yeah, up to first step, sir. Above that, yeah, up to that, I was able to understand. No, now I am clear.
Okay, okay.
Now I am clear, sir. Earlier, I was able to understand only up to that only.
Okay, no problem.
So after that, Z4 you are doing, no? So only that center of D4 elements you are writing and calculating, no, sir. That calculation only is not there in my notebook. Maybe you would have taught, sir, but
Okay, you're right.
yeah. Yes, sir, done, sir.
Okay, next still.
Yes, sir. Sir, here I have wrote the definition, sir, for automorphism. The definition of automorphism is a function which maps from G star to G star, right, sir?
Yes.
Is an automorphism if F is 1 onto homomorphism, that is an isomorphism, and the collection of all automorphism function is also a group, and this one. So what is mean by automorphism? I didn't understand, sir, here.
Automorphism, that is one function only, no?
Yes, sir. It is a mapping you are saying.
Any function, first, suppose you have any function, and for that function, domain, codomain, both are same.
Yes,
and
sir.
that function is 1 onto homomorphism.
Yes, sir.
That only another name giving isomorphism on same domain codomain place. Automorphism means isomorphism function only, but must will be
Yes,
domain
sir.
codomain will be same.
Yes, sir. Yes, sir.
So that function is called automorphism function. And this is a group G star. So G star to G star, how many automorphism function? How many 1 onto homomorphism function? So suppose 2 function coming, 3 function coming. So by that function collection also we can prepare one group.
Yes, sir.
That group is called the automorphism of G. AUT
The
of
group
G.
is okay, sir. So that group is automorphism group, right, sir?
Yeah,
And
collection of
F is
function.
the automorphism function.
Listen, the collection of 1 onto homomorphism function is called a group, and that group is denoted by AUT of G, means aught of G.
Yes, sir. Yes, sir.
Just that set name, that group name is AUT of G.
Okay.
But that is collection of function.
Okay, okay, sir. Understood, sir.
Hmm.
So F is a automorphism function. Automorphism function's collection is automorphism group.
Yes, yes.
Yes, sir. Yes, sir. Then, and sir, here,
Hmm.
are you able to see the screen, sir?
Yeah, I can see.
Yes, sir. Sir, we are writing here x, 2x, and 3x and 4x, sir.
Huh.
Right. Over there, I get confusion, sir. Automorphism of Z of I means
Z5, automorphism of Z5 means Z5 to Z5, who is the
yes, sir.
1 onto homomorphism function.
Yes, sir. Yes, sir. So how we are particularly writing x, 2x, and 3x and 4x should be the function like that. Why not
Z5 to
other?
Z5 is 1 onto homomorphism. You have to give time. If deeply you want to go and deeply going, that is good only, but you are not giving time. Z5 to Z5, 1 onto homomorphism. Who is that function? Define a function. F of x equal to is what? So you try first identity function. Fx is equal to 0x. So 0x not possible, 1 onto and all. Every maps 0 0, many 1 will come. So 0x not possible for 1 1. We want 1 1 onto homomorphism. So Z5 have 0 to 4 elements are there. 0 1 2 3 4. So possible function will be 0x, 1x, 2x, 3x, 4x. So you have to put value and have to check that who is the 1 1 onto and homomorphism. So we have no time on this much on exam hall. You have time on your home, not on exam hall.
Sir.
So you have to check which function is 1 1 onto. First you check. Homomorphism is just preserved condition have to satisfy. So who is 1 1 onto? So Z5 to Z5 you put value. First 0x not possible, 1 1. Many 1 function this is.
Yes,
you
sir.
try fx is equal to 1x. 1x means x function. So x function means 0 maps to 0, 1 maps to 1, 2 maps to 2, 3 maps to 3, 4 maps to 4. So this is 1 1 onto.
Yes, sir. Yes, sir.
2x you try. 0 maps to 0, 1 maps to 2, 3 maps to 6. 6 when coming modulo 5 we have to use, means 1.
Yes,
so 2x I'm trying, no, 0, 1, 2. 3 means 6, that is 1.
Yes,
4
sir.
means 8, 3 will come.
3.
So
Correct.
no any repetition, no. 0 is 0, 1 is 2, 2 is 6 coming, 6 means 1. Repetition is there. Fx is equal to 2x. If you will go, f0 is 0, f1 is 2. No, I thought this is 1. f2 is 4, f3 is 6, modulo 6 is 1, f4 is 8, 8 modulo 3 is 3. No repetition. So 1 1 mapping, 1 1 on 2. Next you go 3x. 3x
Yes,
means
sir.
0 means 0, 1 means 3, 2 means 6, 6 means again 1 will come, 3 means 9, 9 means 4 will come, 4 means 12, 12 means 5, no, 2 will come.
2.
No repetition. So this
Yes,
is also 1 1 on 2. 4x you try. 0 means 0, 1 means 4, 2 means 8, 8 means 3, 3 means 12, 2, 4 means 16, 1.
Yes, sir. 1.
So
Correct.
all are 1 1 on 2. All
Yes, sir.
functions are 1 1 on 2 coming. But here after we have to check preserve condition. Who is preserve condition giving?
Yes, sir.
Correct.
Yes, sir.
So preserve condition means we have to satisfy for all x comma y belongs to Z5, then f of x plus y equal to f of x plus
Okay.
f of y. And here both are same domain, so modulo 5, here modulo 5. So you have to verify this is for every function
Yes, sir. Yes, sir.
and for all x. So you try in home, must will satisfy. For that I told that total 1 1 onto homomorphism for Zn group. This you can write automorphism of Z5. Means collection of all 1 1 onto homomorphism of Z5. So I told automorphism of Zn is always isomorphic with Un. Means nature are same coming. So U5 elements will be 1, 2, 3, 4. And you see that 4 functions are 1, 1, and 2 I am giving only. Homomorphism must will satisfy. So direct I can write automorphism of Z will be X, 2X, 3X, 4X. So from here only coming this is. Their natures are same. So both are isomorphic.
Okay, okay, sir. Okay.
Understanding?
Yes, sir. I was having a doubt of why only x, 2x, 3x, 4x they are taking. So why they are not taking any other function like x square plus 1 and like that?
Listen,
now
we
understood.
can choose any function. We can
Yes,
choose
sir.
any function. I can tell fx z5 to z5. One function I will choose x square plus 1. No problem. But always
Yes.
remember, I have to use this modulo 5.
Yes,
If
sir.
I will put here f of 0 means 1, f of 2 means for 5, modulo 5 is 0. Next 3,
Okay.
9 plus 1, 10. Again 0. See, not 1, 1.
Yes, sir. Yes, sir.
Huh?
Understood.
Yeah, operation will be, I choose this function. 1 addition modulo 5 x. Yeah, possibility. Yeah, next tell, I'm waiting your statements. Maybe not satisfying, but if suppose satisfying also, then you don't count this is 6. 100% this function will be isomorphic with any one function. 100%. This function nature and any one function nature will be same.
Sir, that means no other function, only these
Yeah,
are
only
the
these 4
functions
function.
no other function will satisfy.
No, never.
Oh, so AX, that function only, KX function.
We are reading modern algebra. This x square meaning not x into x.
Yeah, yes, sir.
This is x plus x. This is linear function, not quadratic function in modern algebra.
Oh, yes, sir.
So if this is 1, 1 onto homomorphism coming, no, must Z5 to Z5 and any one function will be same behavior will come. So any one you choose, either x is 1 plus x you choose or 4x you choose. Suppose this is isomorphic with 4x. So either this function tell or that function tell.
Yes, sir. Yes, sir. Understood, sir. One second, sir. Note down.
Clear?
Sir? Sir, next doubt, sir. Sir, automorphism of ZP into ZP into up to
Nth time, yeah.
yes, type nth time. How it is isomorphic with GLN of ZP, sir? Because this is
listen,
yeah.
this is not a doubts. Okay, either you read books or you find automorphism of all functions, otherwise you accept this.
Okay, okay, sir. No proof.
I Z5 to Z5 function I can give. All homomorphism function I can't give on class. I can give when as a research we will discuss.
Okay, okay, okay.
Yeah, this you
so
accept.
Proof is not there for this one.
No, this and all not a theorem. Modern algebra, nothing theorem. Open only.
It is theorem only.
Direct this and all automorphism of Z5 cross Z5 finding means you are think how much function will come. After that, that
Yes,
nature
sir.
will come with same with general linear group. Then every nature have to match. So this
Yes,
and all
sir.
you have to accept only.
Okay, sir. Okay.
This and all can tell just a result.
Yes, sir. Okay. Sir, here, but sixth order element does not exist in S3. Case failed, we are writing, so that why it's
1 minute. What is that?
it's not
S3.
Yeah, yes, sir. Yes, sir. S3.
Why
Why the
okay, you
case
are
is
going.
failed here?
1 minute. Question is what? S3 to S3 total group homomorphism.
Yes, sir.
Okay.
Total.
Your
this is the
kernel
question,
is
sir. Find
identity,
total.
correct? Case first.
Yeah, yes, sir. Kernel is
Kernel
identity.
is identity. So S3 by identity, if you will do, then that is the 6. So
Yes,
S3 by identity is isomorphic with image of codomain.
Yes, sir.
So S3 by identity is itself S3. And 6 order subgroup also existing in codomain, that is itself. So S3 by identity is S3 itself. So isomorphic with S3 tail or equal to S3 tail, both are same. But for group homomorphism, we want that group order element. Because that group order element only we are counting total group homomorphism. But 6 order elements does not exist in S3.
Yes, sir.
So we can't count the total group homomorphism from case first.
Sir, board is
What?
Sir, can you explain in board, sir?
Board what I will write? S3.
To write something, yeah, it is
S3,
very easy for us.
S3 by identity
Yes,
is S3 only, no?
yes, sir. Yes, sir.
And isomorphic with image of F. So
Yes,
first image of F is okay. First this F, who is that F? So S3, our domain is S3 itself coming by case first. Case first is kernel of F is identity. So G by kernel of F is isomorphic with image of F. Our codomain is also S3. So here after isomorphic, no need to write. Direct our 6 order subgroup is S3.
Yes,
Correct? So S3 equal to S3 here coming. But
yes, sir.
6 order element does not exist in codomain.
Yes, sir.
In S3, in your codomain, only 1 order element, 2 order element, 3 order element is
3
there.
order element.
No any 6 order element is there. So 6 order element not have the function not possible to define, because total 6 order element in codomain only will give total group homomorphism.
Okay, okay, sir.
So this case is fail going.
Yes, sir. Yes, sir.
So this is isomorphic coming also waste. Image of F we are writing. Function first group homomorphism here not possible, because 6 order element does not exist in S3. No any function will exist. Means this kernel not possible. Means which function homomorphism will give, by that function this kernel is not possible.
No, so that 6 order element does not exist, you are saying, no, sir.
Yeah.
That point only, again, I have problem.
You go case 2, you go first. Then you will understand case first. Case
Yes,
2
sir.
you go.
Yes, sir. Case 2, kernel is A3, sir.
Yeah.
Normal subgroup is A3.
Kernel is
And,
A3.
Yeah, yes, sir.
So here if you will go G by kernel of F means S3 by A3. So S3 by A3 order is what?
Order
2.
is 2, sir. 2.
And 2 order subgroup also existing in codomain.
Yes, sir. Yes, sir.
Correct. So S3 by A3, I can write isomorphic with image of F. And image of F is a 2 order subgroup. Image of F is always subgroup of codomain. So this group is order 2. So 2 order subgroup we want. Two order
Yes,
subgroup
sir.
in S3 who is?
S3, the transposition element.
Identity
Trans
and two order element.
identity 1, 2. Yes, sir.
And we have three types are there. Identity
yes,
1,
sir.
2, identity 1, 3, identity 2, 3. But
2,
all
3.
are isomorphic together. Equal to don't write. Here after identity 2, 3, identity 1, 3. So two order, we have three elements here. Two order, we are getting isomorphic subgroups. Hereafter, that we are counting total number of group homomorphism is total two order element. So total two order element have in S3 is 3. So three group homomorphism possible. Maybe that group
Yes, sir.
homomorphism possible 1, 2x, 2, 3x, 1, 3x. So three group homomorphism will come. So your previous case, 6 order element also we want to know.
Yes, sir. Yes, sir.
What is 6 order element in S3?
Yeah, it's not available.
Finish. From that order element only group homomorphism we are preparing.
Yes, sir. Yes, sir. From that order element only, group
Yes.
homomorphism we are preparing. Okay.
Yes.
Okay. Yes, sir. That point only, the last point. Correct.
For that I told case 2 understand, case 1 automatic will understand.
Yes, sir.
Yeah. Whatever element have been set, from there only function will exist. I can write Z5 to Z5 x square function also. X cube also I can write. But that x square must, if one onto homomorphism, no, must anyone isomorphic. Maybe x square equal to 2x. Maybe x square equal to 3x. 2x only. X square equal to 2x only. Because this is modern algebra. 2x means x square I can tell. 3x means x cube I can tell. 4x means x power 4 I can tell. Just whenever modern algebra reading, don't mix real and modern. In real analysis, x square means x into x. Modern algebra means x plus x.
Yes, sir. Yes, sir.
Next.
Yes, sir. Sir, this one. Sir, inner automorphism of Z4 is equal to one second. Is equal to phi naught we are writing. Then how inner inner of G is isomorphic to G by Z of G.
Listen,
How
inner
we are writing.
automorphism of any group is isomorphic with G by center of G. First, inner automorphism you can neglect also. Is still not coming on any example. No any example.
Oh.
This is out of syllabus. Myself I am giving. So,
Okay, sir.
but we will understand. Any type of, if anything you are not understanding, no, try to go by contradict. Suppose Z5 not understanding, go D3, D4, you will get problem, no automatic understanding will come.
Yes, sir.
So inner automorphism of Z4, suppose I am writing. So inner automorphism of G, what is the definition of inner automorphism? We are denoting function is phi A. Like that function we are denoting. A is the element of for all A belongs to G. So inner automorphism of Z4 means phi 0, phi 1, phi 2, phi 3. 4 type of function possibility. But inner automorphism of Z4 will give only one function because all are equal. All functions are equal. And any two functions are equal. What is the meaning of equal function? When our same elements maps to same elements, that is called equal function. In phi naught also 0 maps to 0, 1 maps to 1, 2 maps to 2, 3 maps to 3. Phi 1 also 1, 0 maps to 0, 1 maps to 1, 2 maps to 2, 3 maps to 3. Phi 2 also 0 maps to 0, 1 maps to 1, 2 maps to 2, 3 maps to 3. Phi 3 also 0 maps to 0, 1 maps to 1, 2 maps to 2, 3 maps to 3. So functions are same. So any one distinct function, inner automorphism of G, distinct function have to collect. Yeah, phi 0, anyone right? Phi 1 right? Phi 2, all are same function. So identity function.
Okay, sir.
Yeah, whenever domain codomain same and same mapping coming, identity function. Identity function means like that only. So inner, suppose
Okay.
here problem coming, then you can go with inner automorphism of D3. Just you give time in pen and paper. Inner automorphism of D3 you can denote phi r naught, phi r 120, phi r 240, phi p, phi q, phi r. But all functions are not same. You find that in this is identity function form will come. So R0 to R0, R1 120 to 120, 240 240, P to P, Q to Q, R to R. So one function must will come like this. And I think phi of R120 and phi of R240 will be same. You did or not, I don't know. I told always do. Nobody is
Yes,
doing.
sir. Yes, sir. Sir, correct. Understood, sir.
So you check it. Phi R120 maps are how going, and phi R240 maps are how going. If same type mapping have, means both are equal function. So this much we have no time on exam hall. At least do in home at least. Whatever I am telling. The doubts will clear. After that exam hall, this and all use. Inner automorphism of G is isomorphic with G by center of G. Any group you see. And I think here everybody distinct will come. Because D3 by center of D3 only identity, R0. So D3 by R0 is D3. So inner automorphism of D3 will come. All our distinct map will come. Isomorphic with D3 by center of D3. And center of D3 is identity only, R0. And this is isomorphic with D3. So inner automorphism of D3 is isomorphic with D3. This meaning all functions distinct will come.
Yes, sir. Yes, sir.
Next.
Sir.
Mm.
Yes, sir. Here, G is isomorphic with. Actually, it is some something is missing here. I think
9 order. Something writing.
9 only. No, sir. Should actually because, no, sir.
You are writing.
Order,
I can see.
Yes, sir. Actually, order of group is 9, so it should be isomorphic with Z9 only. No, sir.
Why?
Why?
If
because
listen,
the group is,
you
sir,
go
9
previous chapter. You go previous chapter. I gave one
yes,
finite abelian group chapter.
Finite
Read stepwise. I am teaching stepwise. So read stepwise. If you have 9 order, any group have unknown group, your 9 order is there. Then how many abelian group possibility?
Yes, sir. Yes, sir. Yes, sir.
2.
How many abelian
3 square. Then you have to
3
do
square.
partition of 2. Then partition of 2 is 2 will come. 2 and 1 plus 1.
Yes, sir.
So 2 abelian group. In that one must be cyclic, another one must be abelian. And 9 order, no any non-abelian will come. Either you check from dihedral group, check from SN, check from AN, no any non-abelian group. P square group is always abelian.
Always abelian. Yes. Sir.
Yes. In that one is cyclic, another one is non-cyclic but abelian.
Yes, sir. Yes, sir. No, sir. My question is, this is Z9 only. No, sir. Should come.
Ama.
That is 3 I have written, sir. That's why.
No, Z9
Actually,
will
it's
come
9.
now.
Yes,
Z3
sir,
square
Z9.
can write that is.
Yes,
Z3
sir.
square.
That is only my confusion actually. Whether it should be Z9 only. No, I have written Z3. So, yes, sir. Sir. Then here G is isomorphic with we are writing 12.
Yeah.
Right, sir.
Yeah, 12 order group.
Sir, I think, yeah, yes, sir. Sir, I think I'm asking one silly doubt only. But anyway, let me ask, sir.
Okay, no problem. You ask.
Yeah, yes, sir. So order of G is equal to 2 square into 3. So we are writing this could be isomorphic to Z6 into Z2. And then why not Z4 into Z3, sir?
Z4 cross Z3. 4 and 3 GCD is what?
4 and 3 GCD 1, sir.
So Z4 cross Z3 is isomorphic with Z12. Both are same. So either Z12 right or Z4 cross Z3 right. Anyone can write.
Oh, okay, sir.
Already Z12 writing now.
Yes, sir. Yes, sir.
There itself you can write isomorphic Z4 cross Z3.
Yes, sir. That is the confusion, sir. Sir? Sir, the statement I'm having doubts, sir. If order of G is P square into Q square, P square does not divide Q square minus 1 and Q does not divide
already you, by chart of groups I gave all general whatever generalization I wrote from chart of groups only I wrote. But after that also we have some unique groups that and all some generalization available have.
Okay.
Suppose Z2 square into 3 square means 4 into 9 36 Z36 or 36 order group. So 36 order group they will tell sometime coming that which of the following orders are only for abelian groups, only for non-abelian groups, like that sometime they are question asking. So in that suppose 36 order they will give. So 36 order means 2 square into 3 square. So like that this formula and all you can use there. If 2 square does not divide 3 square minus 1 but will divide I think. Because 2 square means 4. 4 divides 3 square minus 1 is that is 8. So dividing means non-abelian group possibility from there. So you can't tell 36 order group is a abelian group only. But if we'll satisfy this P does not divide Q square minus 1, Q does not divide P square minus 1, then that is the abelian group possibility.
Okay.
If you want clearance, then you have to go with like that group and every elements have to find and you have to do. Then only clearance will come. Otherwise, no.
Yes, sir.
So direct you apply this and all.
Yes, sir. So by theorem, they found all those things and we are reading only the statement.
Yeah, everything we can't clear. No, till 15 order group, everything clearance I gave. And which sometime we don't know about 36 order group, 72 order group, 100 order. We don't know. We have no time this much. You go by silo.
Yes, sir.
Last one before 1 week or before 2-3 days, one question I put, that Prabhu asked with me, I clear him. Yeah, that question, little see everybody in group, nobody is giving answer. What is that? 57. That 57 only. Somebody 19, 57 minus 19 and all giving answer. Order of G is 57. And what is that question? See that question. In that, I think asking total 2 order element or 3 order element asking. Three order element total asking. You see how much twist is there, how much they are trying to prepare you confuse. Yes, non-cyclic group. Okay. Means by this question you try to catch. They don't want that you qualify this exam. They want to prepare you full list, confusion, everything. 57 order group if we are going, prime factorization we will do 19 into 3. Okay, both are prime PQ. We don't know about 57 order cyclic or abelian or non-abelian, anything we don't know. We can't tell exactly what is that group. So, but we know total possible abelian groups, how much can find. So you think here 19 into 3, both prime factorization doing, power is only 1 have. So only one possibility for abelian group, and that will be the cyclic. Only one possibility, no? Only one possibility for abelian. So that is the G is isomorphic with Z19 cross 3 means Z57 only. Yeah, non-cyclic. So cyclic have, if they will tell cyclic only, then we can go from here, and total 3 order element is 5 of 3. Direct we can tell, but they don't want this. Question itself writing non-cyclic group. So our test fell. We have to think about next. So non-cyclic means abelian group possibility, non-abelian group, or non-cyclic means abelian also. But already we know that only one abelian possibility, and non-cyclic telling, this meaning that is non-abelian group. But 57 order non-abelian group we can't tell. Maybe from Sn, maybe from An, maybe from Dn, not possible because Dn means twice time. So we can't tell about a non-abelian group any order. Okay, then how to find? Then you go by silo. Okay, silo if you will go, then 19 into 3, both prime factorization is there. The 19 silo subgroup existing of order 19, and 3 silo subgroup existing of order 3. So silo telling 2 subgroups are there existing, one 19 order, one is 3 order. Just this is name. Don't fear, this is what, just H1 and H2. 19 silo subgroup, that is one name. Means H1 is a subgroup of order 19, H2 is a subgroup of order 3. So hereafter, first I am going 3 order subgroup. That how many 3 order subgroup will exist? So N3 means 1 plus 3k. Okay, and k is equal, I told k is equal to 0, 1, 2, you put and check it, how many subgroup will come. If k is equal to 0 means 1 will come, N3. K is equal to 0 means N3 is 1, 1 must will divides. K is equal to 1 means 4, what 6 will come. Yeah, k is equal to 6 means 18 plus 1, 19 will come. So k is equal to 6 means N3 will be 19, and 19 also dividing order of G. So two type of possibilities is there, means 3 silo subgroup of order, Santosh understanding? 3 silo subgroup of order 3 is 1 or 19. Correct? 1 or 19. So we don't know exactly from here. We can't find. If suppose 3 order subgroup is only 1 coming, then this meaning that their identity will be the 1 element, and remaining 2 must be 3 order element. If 3 order subgroup is 19, then every 19 subgroups have 1 1 1 1 identity, and remaining 3 order elements will be there. Correct? So we don't know exactly from here 1 or 19, so we can't do anything from here. So we will come here after 19 silo subgroup, how many existing? So N19. N19 is 1 plus 19k. Okay. N19 is 1 plus 19k. If k is equal to 0, then 1. K is equal to 1, then 20. K is equal to 2 means 39. Will increasing only. Means here only one possibility will come. K is equal to 0, then N19 will be 1. So here confirm have then 19 silo subgroup of order 19 is 1. Means 19 order subgroup is only 1. Suppose that name I am giving H19. Correct. So H19, only one subgroup is there. First will be identity. Remaining are 19 order element. 19 order element. What is 19? 19 is prime. See how type confusion we can come outside. When when we are suppose, here will come later. Suppose 10 order subgroup I am preparing from any group, and 10 order elements, 10 order subgroup we are preparing means first identity and 10 order element we want. Suppose 10 order subgroup means total 10 elements we want must. In that one will be identity, remaining all will be 10 order element. Maybe 10 order element we won't get 9. Maybe 2, 4 like that. Suppose 10 order element we have 4. So 4 I put. Then total 5 element only came. No, remaining 5 element who will come? Correct. So in that 10 order subgroup, possibility have 2 order element will exist, 5 order element will exist. Understanding? Suppose 12 order subgroup. In 12 order subgroup, identity also possibility, 2 order also possibility, 3 order also possibility, and 12 order also possibility, 6 order element also possibility, 4 order element also possibility. But if you are prime order subgroup preparing, suppose 5 order subgroup preparing, then identity and 5 order element only will come. In 5 order, 2 order, 3 order not possible. If 7 order subgroup preparing, then identity and 7 order element. No, don't think like that. Abelian, non-abelian, I am not going. Leave it that. I am how we are arranging subgroups. Now, just now in D4 we saw 4 order subgroups we are preparing. 1 order element identity came, and 4 order only 2 elements have R90 and R270. But who will come next? 2 order element only possibility. Correct. I am here want to tell even order subgroup and odd order subgroup. Odd order also not. Prime order subgroup. Understanding? Even order subgroup when you are preparing, suppose 6 order subgroup preparing, if your 6 order element is less than coming, then 2 order element you will take, 3 order element you will take. 7 order subgroup if you are preparing, then 1 will be the identity and 7 order element we want. In 7 order subgroup, 6 order element not possible. No? Understanding what I am telling? If 6 order subgroup you are preparing, then 6 order element will come, and any element is 6 order. What is the meaning? That power 6 is the identity. Suppose 6 order element less have, then 2 order their possibility. Why 2 order their possibility? Suppose B square is identity and B is a 2 order element. Here whole cube I can give, no? And B power 6 will be identity. Means 2 order element we can prepare 6 order element. 3 order element we can prepare 6 order element. But when prime order subgroup you are preparing, then identity and all prime order element we want, otherwise not possible. If 7 order subgroup preparing means any element is 7 order element, then you tell that any power 7 will be identity. 2 order element we can't do. 3 order element we can't do. If any A square is equal to identity, then we want here power 6 we are preparing. No? So A square can prepare power 7. A cube can prepare power 7. Not possible. So 7 order subgroups means identity and all 7 order element. Prime, next prime 11 order, 19 order. So like that here, when 19 order subgroup is only 1, then first is identity element, remaining 19 order element is 18. Correct. All A, B, C, D, ... all are 19 order element, this all are. So in this G, total 19 order element is 18. Correct. In this 57 order group, total 19 order element we got 18. Another one order element. Total how much coming? 3 order element here after one. So here after you come back, still 3 order, not clear answer. We will hit this here. 3 order subgroups either 1 or 19. If 1 going, then by this 3 order element is 2 only. So here 2 I will add, then 21 will come, no? But group order is 57, no? So this, by this, no, maybe they can ask with you also that total 3 order subgroup how many? So 1 not possible. So 3 order subgroup 100% guarantee 19 will come. Understanding? And 3 order subgroup total 19 have H1, H2, H19. All are 3 order subgroup. So first element will be identity, remaining to 3 order element. Identity, 3 order element. Identity, 3 order element. So 3 order, how many elements coming? 19 have?
19.
No, here how repetition will come? Prime order have no. All distinct want only no. Will increase otherwise or will less will come. Understanding? If suppose repetition I am coming with you, then 57 less than will come no element. Group order is 57 no. No, we have to say by silo we have to go like that. Yes. By silo we will tell 100%. What? Okay. Subgroup is distinct, but elements are not distinct. No, where element have to count. No. So 57 element. What we want total 3 order elements in from non-cyclic. So 3 order elements exactly how we will tell. So from subgroups only. And we have here 2 type of subgroups, 1 order, 19 order. 19 order subgroups is clearance have only 1. From here 19 into 2, 18 elements are here. Our groups order is 57. In that 1 element is identity, remaining 19 order element is 18. So total 19 element is here. So 57 elements are there. In that 19 we will subtract. Then whatever elements will come, that is our 3 order element only will come now. No, after that why you are going? After that we can't go. 57 order cyclic group, whatever will come, no, silo no. For that silo gave these concepts. You and me don't know. For that only he gave this concept. And exactly 57 order subgroup, 57 order groups, these 3 types of, 2 type of subgroup only possibility, 3 order and 19 order. And by these concepts, we can tell that 3 order, if you will tell by this, we will go this side. If they will ask 3 order, how many subgroups are there? What you will tell? 1 or 19? So by this concept, by this, we can tell 100% that 3 order subgroups are 19. 1 not possible. Because group total elements we want. And by this group order, you have to accept here that 3 order, 19 subgroups are there, and every places 3 order elements are distinct only. You in your mind confusion coming, then delete that. No, not possible, because we have 57 order element, 57 group order. So 19 order element is 18, 1 order identity. So remaining all are distinct only. No, then only subgroups we can prepare. No, then how I can think that maybe repetition will no. Yeah, then possibly will increase if repetition coming means. And prime order, whenever we will do no, that place repetition very rare possibility will become. Identity and completely prime order element will be there. More than we want. If 3 have 4 have more, then we want distinct. So like that concept, and after that, yeah, 57 minus 19 you do, or from 19 into 2 you do, anyone. 19 into 2, 38 elements are there, 3 order elements. Simple. If they will add that G is a not simple. If G is a simple group, if we'll give no, then this case will fail, because the 19 order subgroup is unique have, and that will be the normal subgroup. And this group is not simple only because here normal coming. Already not. Yeah, you can eliminate from here if only one existing then. But here already normal subgroup coming. So automatic this is not simple. If G is a simple group telling, then direct this have to neglect. Cancel and this cancel, then direct 19. And when here will add no, G is a simple group, then you are neglecting this, and then you are neglecting this, then your statement will be correct. That 19 order subgroups have, sorry, 3 order subgroup if 19 have, then identity remaining 2 is 3 order element. Maybe any place anybody will repetition, then exactly total 3 order element we can't tell that time. That time, if G is a simple group, if you will add then. But here, if exactly we want, all are connected here. Have all are. Santosh, next ask.
Yes, sir.
Sahana, who is the Sahana Litika?
Yeah, I'm only, sir. I'm only, sir. Actually, I have
Okay.
connected by one more device.
Oh.
And now connected with laptop, sir.
Okay.
Yes. Sir, then here I have written how Z is identity element. If Z is identity element, then 1 plus Z is equal to 1. No, yeah. Yes, sir. Sir, here we are writing Z is an identity element. Then 1 plus Z should be equal to Z only, no, sir. Then identity means some confusion here. So 2 days back I prepared, right, and I have written this down.
This is you are preparing from Q by Z, correct?
Okay. Yeah, yes, sir.
Q by Z. Quotient group. So Q by Z identity element is E plus Z. E plus Z means 0 plus Z.
Yes.
0 plus Z means your Z. So Q by Z identity element is Z only. And
yes, sir. Correct, sir.
in Z, 1 plus Z, 2 plus Z, 3 plus Z, this all are same set only.
Yes, sir. Yes, sir. 1 plus Z, 2 plus Z, everything is Z only.
Yes. So A plus Z, if A is your integer, then always A plus Z is Z.
Yes, sir. That's what.
So no need to count separate one order element.
Yeah, yes, sir. That's okay, sir. But why Z is called as identity here? Whatever we are adding with Z, we are getting again Z. So,
yes.
So Z is identity we are writing.
Yes.
Right, sir. Okay.
And any type of quotient group G by H, H is the identity only, no?
Yeah,
so
yes,
Q
sir.
by Z, Z will be the identity only, no?
Yes, sir. Yes, sir. Clear, sir. Clear. Sir, in the actually some definition, sir. Definition of principal ideal. What is the definition? Principal ideal and ideal. What is the difference between both, sir? Ideal will be principal ideal means always it will be cyclic or else, because same here and there I have written same concept.
Cyclic, why you are telling? That is group, no? This is when ring you are entering, then cyclic, not that is, no. Ideal,
Sir,
when any
yeah.
first ideal means your left ideal and right ideal both will belongs, that is called ideal.
Yes, sir, correct.
But
Correct.
principal ideal means if that ideal is generated by any single element, then that is called a principal ideal. Finish. And generating means
yes,
AR. Here not A square, A cube. Cyclic group, not this is.
Yes,
Some
sir.
when we are finding ideal of Jaden, and Jaden is cyclic only. So by that help, we are telling here, okay, whatever generator we saw in cyclic group, that only here ideal generator. But there in cyclic group, A square, A cube, A power 4 we are reading. Here A into R we have to read.
Yes, sir. Yes, sir.
AR or RA?
Yes, sir. AR or RA.
Huh. Because your R is a commutative ring, no? So IR and RA
Yes,
both
sir.
will be same.
Yes, sir. Yes, sir. So it is generated by A we are writing, right?
Yes, generated by single element, then that is called
Single
a
element.
principal ideal.
Yes, sir. Because in that definition also I have written like that. It is generated by a single element for definition of ideal, sir.
No, ideal
Left
plus
ideal, right ideal are equal. Is generated by single element A.
when
there also
listen,
single
listen,
element
when
are-
listen, your definition of ideal telling and reading in R commutative place. When R is a commutative ring, that time left ideal, right ideal both are equal. But definition of ideal is different.
yes,
Definition of
sir.
ideal means a subring is
Yes,
ideal when that subring will contain AR and RA both.
Yes, sir. So that is only ideal.
Ideal, huh?
Yes, sir. So principal ideal means
That
it
same
should be a
ideal,
commutative ring.
yeah,
same
principal ideal when you are going, that time first your ring will be commutative. After that, whatever ideal already you have, you check it. That is generated by only particular element. Generated by 2 or generated by 4. More than
Yes,
one
sir, yes,
possible,
sir.
but particular, separate generating.
Yes, sir.
More than one ideal generating, no, we are just, I am giving generalization. We are not reading. That
Yes,
is
sir, yes, sir.
asking direct there. We can't find big function. We have to choose more than one ideal generating means generated by
Yes,
X
sir.
and Y both together.
Yes, sir. So it is
Polynomials,
generated by a single
polynomials also
element.
generated
So,
by single element means principal ideal.
yes,
Yeah,
sir, yes, sir.
not only constant. Any, I will write this X square plus 1 generating. This is ideal, principal ideal, generating by single polynomial. Two polynomial generating X square plus 1 and X square plus 2. Then this is not a principal ideal.
Yes, sir, yes, sir.
But this and all very
Okay,
big
okay.
function will come. This ideal if we will explain means that
Yes,
much
sir.
we don't need.
I got confused with cyclic groups.
No,
So
no,
it
no,
is
no.
generating by a single element like A power 1, A power 2, like that.
No, no, not like that. AR.
Yes, sir. Yes, sir.
Sometime matching with same concept. So I told cyclic you can use. Jaden ideal are same cyclic subgroup ideal.
Yes, sir. Sir, next one, sir. Q of D. How Q of D comma plus is a field, sir. So field definition is it should be an abelian group with addition and for
This all
non-zero
are
element
extension
inverse should
field.
exist.
Q box, root D and all extension field only. All are field only. Field property must will satisfy.
Okay, sir.
Extension field read. Q box, root D means.
Extension.
Yes.
Yes, sir.
This and all you have to give more number times. Then only will clear. Ring field
Yes.
compared to group is more. Ring field little syllabus, but tough that is compared to group.
Yes, sir. Next one.
First, that name and all, you will think that first time listening, and last time maybe. That I feel
Yes,
coming.
sir.
But time will give. No,
Any
after
other?
that is easy.
Yes, sir. I've gone through fully, not fully. I have gone through, sir. Only here and there, some confusions are there. And
Baapre, full black color coming. Why again rain is starting to on now? Baapre, yesterday night got irritated more.
yes, sir. Sudden rain, sir. Sir, here, this is actually Z3I is a field we are writing, sir.
Yeah.
Z3I is a field. So how it is a field, sir? Z3I.
Z3 is a field. How asking? You read one time notes here after. Next time you ask next doubts. ZP is a field and all.
Z3 is a field, sir.
Yeah, Z3 is a field. Z3 box I is a field or not, you have to check. Z3 box I element first find.
Yes,
after
sir.
that check it.
Yes, sir. Yes, sir. So the Z3 box I means it is like
A plus IB.
Complex number, sir. A plus IB. And
yes,
then
A and B
the
from
A
Z3.
and B from Z3, sir. How will I come to know? How will I see it is a field, sir? So every multiplicative, non-zero multiplicative inverse exists.
Yes.
Right, sir. So all those things we need to check, and then only we can finalize it. Right,
yeah,
ZP.
First ZP is a field only always. Field property will satisfy.
Sir. Yes,
but
sir.
ZP box I you have to verify. You can't tell ZP box I always field. Not like that. ZP box I you can go field as a integral domain. You check it ZP box I for which prime that is integral domain. Because every finite integral domain is a field.
Yes, sir. Yes, sir. Finite integral domain.
So Z3 box I you check it. Without zero divisor have means that is a integral domain. Then that is a field. And every field is a principal ideal domain.
Yes, sir. Every field is a principal ideal. That I know. Sir.
Yes. Z3 box I is a field will come. You open and try to find.
Okay. Okay, sir.
Every time, no, you can't verify field definition also.
Yes, sir.
This is a finite set. You check integral domain or not. If finite integral domain must field because every finite integral domain is a field. If not integral domain, then not field. And integral domain means you check it zero divisor or not. If without zero divisor have, then integral domain. Zero divisor is there, then not integral domain.
Yes, sir. Sir. That integral domain, all those things prepared, sir. So this is one we need to work out your thing, right, sir?
Z3 box I. First you write all elements.
Yes, sir.
Nine elements will be there. And after that, you check it who is the zero divisor element. If no zero divisor element, then that is an integral domain. After that is a field.
Okay, sir. Every finite integral domain is a field.
Yes.
So
yes.
It is okay. Okay, sir.
Because every time under addition abelian and under multiplication abelian,
yes, sir.
Possible to check.
Yes, sir.
Podumpa.
Sir, once again, sir. Yes, sir. Sir? Yes, sir. This one, sir. A15 0 into 0 cross 0 into PZ. Why it's not prime? We are right. I'm writing correct.
This is not prime
it is
ideal.
not prime ideal. Yes, sir. Not
Because,
prime ideal.
not
Why
prime
it's not
ideal.
prime?
You see, counter example I gave there. Prime ideal definition is two non-zero elements you have to choose from your
Yes, sir.
ring. Their product will belongs to that ideal, but no any
Yes,
elements
sir.
will belongs to that ideal. Then that is not a prime ideal.
Yes, sir. Yes, sir.
So you see, next counter example you are writing.
Yes, sir. 102 and but this is for something else, right?
102 and 013 can write. That both are from your given ring,
Yes, sir.
but their product will be 00, I think 6. What is
Sir,
ring?
product is 008. I'm getting 102 comma 024.
Wait. What is your ring? Given ring is? Question.
Question is this one, sir. 0.
That is your ideal you are giving
Okay.
now. Ring,
Yeah,
ring.
yes, sir. Yes, sir. Ideal. Yes, sir. It is
Q.
R
What is
into
that?
Q into Z, sir. R into R
real,
cross Q cross.
rational, and integer. And
Yeah,
you
yes,
gave
sir.
me one ideal. What is that ideal?
0 into PZ. 0 set into 0 set into
PZ.
PZ.
Means
Yes,
0, 0, Z. And Z belongs to PZ.
yes, sir.
Telling this is not prime ideal.
Yes, sir.
Prime ideal definition is two elements we have to choose from ring. Their product will be belongs to ideal, but any one elements must be from ideal. If not getting,
Yeah,
if are
yes,
getting
sir.
contradict, then that is not a prime ideal. So you see, I will choose from ring two element, that 0, 1, 2 and 2, 0, 3. These two elements from ring I am choosing, given R from here. Their product 0, 1, 2, 2, 0, 3. If we will product, then 0 into 2, 0, 1 into 0, 0, and 2 into 3 is 6. So 0, 0, 6 coming, and 0, 0, 6 will belongs to here for any prime.
Yes, sir.
So belongs to, suppose this is A. So ideal belonging. But any one belonging ideal?
No, sir.
No. And this is a contradict. So this is not prime ideal.
Okay. Okay.
Yes. No contradiction, then that is a prime ideal.
Sir? Sir, the example which you have taken, no, sir, 0, 1, 2 and 2, 0, 3. Sir, both are from R, but the product is belongs to
ideal.
Yeah, ideal, sir. But that means it is prime only, no, sir. So it is
Both
satisfying
are
the property.
their
No?
definition you see, no. Anyone. Product will belongs to ideal implies that anyone from ideal must. Definition I wrote again, no?
Yes, sir. Yes, sir. Yes, sir. Understood, sir. Okay, sir.
Okay, hereafter another rain going. I will go hereafter. Yesterday I full wet.
You're going, sir, now?
Yeah, little will stop me. Suddenly I will go because when will increase full speed on.
Yes, sir.
Already Corona increasing. Omicron
Yes,
coming. Don't know what will happen again.
Sir, the symbol I wrote, it is isomorphic only, no, sir. Actually, it is not equal, isomorphic only.
Yeah,
Yes,
isomorphic.
Sir, here,
Ah.
this is actually degree of extension definition, sir.
Hmm.
Definition of degree of extension. So E is to F is equal to N. But
Ah.
here equal symbol is wrong. No, it should not be. Equal to again.
Oh, equal to
E
again
of
means
it.
that is the meaning. What is that N? That meaning giving.
Okay, sir.
And what is that
So
N?
E is-
N, that N is the dimension of that extension field.
Yes, sir.
Before degree of extension, we are reading that every extension field is a vector subspace of over the subfield F. So that extension
Yes, sir.
field is a vector space and a vector space dimension, and that dimension only will be the degree.
Yes, sir. Yes, sir.
So that N equal to means about N, that is. What is that N?
Okay, sir.
Papa, you want to stop maybe another day hereafter?
Yes, sir.
Hereafter Galois field, Penlav, Digna.
Sir, I think. Yes, sir. Sir, that's all, sir.
Oh,
Only two are there, sir. That's all, sir. It's a simple doubt only, sir. Sir,
Okay.
this is a Galois field, no, sir.
Ah.
I think I have written full page, sir. Can I come, sir, daily? Otherwise, directly, because the full Galois field, no. Hereafter, from here, I
This is
didn't
not a, this is
understand.
not a Galois field. This is extension
Hmm.
field only.
Yeah, extension field, and then afterwards, this extension field.
Galois
sir,
field
this
crossed.
I didn't
Galois
understand,
field.
sir.
Ah.
Galois field is not there, sir, in syllabus.
Yeah, have.
Yes, sir. This one actually, sir, this and all how we are writing, I don't know, sir.
One time revise notes. Everything given have. Q box root 2 over the field Q is 2. You see Q box root 2 I explained. A plus B root
Yes,
2.
sir.
Q box root 2 elements are A plus B root 2.
Yes, sir.
So-
A plus
so-
B root 2. That
So
I know,
Q
sir.
box root 2 is generating by two elements, 1 and root 2. So that is the basis element. So 2 dimension over the field Q. That only writing here. Explanation before I gave. After that here direct writing. You see notes. Properly
Sir,
extension. No, before. This is not. Before go. Complete extension field
yes,
starting.
Sir. Yes, sir. Yes,
You
sir.
see here. Just this and I'll read everything explanation given have.
I've gone through that, sir, fully.
No.
Afterwards, the step only I didn't understand, sir.
Okay,
The
try
step
again.
what-
Again try 1 time, 2 time, 3 time. Not easy this and all.
Yes,
Yes,
sir.
degree means dimension only.
Sir, this division, how it is equal to 2, I am asking, sir. That is only you are saying.
You go your back notes. Explanation you read, Santosh. Explanation is there, no? Q box root 2
Okay.
comma I you see.
Yes, sir.
Over the field root 2 going means P plus Q root 2 elements is there. That is the over the field Q box I. So Q box root 2 comma I over the field Q box I 2 dimension 1 and root 2. But same when P and Q place we are applying A plus IB and C plus ID, then 4 dimension coming over the field Q.
Sir, sir.
And basis set will be 1
sir,
root 2
sir,
I root
that
2.
point alone, that point alone, can you do it in board, sir? Just what you are saying, sir, that only over the phone, if I listen, then I'm not able to understand. Sorry, sir.
In your notebook everything have you properly peace mind, you will think means no will come. Everything
Yes, sir,
stepwise is there have. Wait.
No, I have gone through fully, sir, notes and all.
Q
After that
box
only
root
the,
2.
yeah.
No. You are one time reading means enough. Still I am getting sometime confusion writing what I am writing.
Correct, sir.
Q box root 2 means A plus B root 2 type elements.
Yeah, yes,
AB
sir, correct,
from
sir.
Q. So AB from Q, this is the over the field. So you can write basis set of Q box root 2, anything, root 2 or root D, any type of D. For all D belongs to integer. Basis set of Q box root D over the field Q. First you see what is the over field here. Then two basis set, 1 and root D. For all D integer respectively. So two basis set. So two dimension over the field Q. So dimension or degree, whatever you want to write, of Q box root D over the field Q is 2.
Yes, sir, correct.
D belongs to integer. Q. D1. D1 means only Q, that is Q only. Then 1 how will come here? Then the A plus B direct will come. Then only rational, that is. Okay.
Yes, sir.
Otherwise, you are thinking 1, 4 like that will come. 4, yeah. 4 and all, then you have to write D will be the 2, 3 prime numbers. Minus also no problem. Positive plus minus P can write. Correct. If D belongs to integer, writing means 4 is 2. Integer, integer also no problem. If 4 I am choosing, so then Q box 2 will come. Then A plus B root 4. Root 4 means 2. A plus 2B will come. Means generating by 1, 2. Correct. Then nothing difference will come, no? Because that is fully rational. A plus 2B or A plus 3B, that is fully rational only. Yeah. Plus minus P can choose. Negative also no problem. Q box I am giving no -1. Q box I, Q box minus I, anything have? Yeah, plus minus I, we are getting x square plus 1. X square equal to x square plus 1 equal to 0 means x is equal to plus minus I. Then plus minus P, right? No problem. Okay. So anyhow, dimension over the field this is. Hereafter, if you will go more than 1, suppose root 2 comma I you told like this. So when elements is increasing, then field here have to partition have to do. Here you can write one elements take outside. This is the now full field. F box I. Okay, or you can choose anyone. Wait, first I will do this. So now here after over the field Q box root 2, same type explanation have to do. And now this set will generated by P plus IQ. P and Q both are Q box root 2. Because this is our F. Okay, so now here we can tell Q box root 2 comma I over the field Q root 2, 2 dimension. Basis set is 1 and I. Here basis set
Yes, sir.
is 1 comma I. Over the field this. Again this I will open. When P and Q both are Q box root 2, then PQ elements is A plus B root 2 type. So write A plus B root 2 P plus and Q plus write C plus D root 2. And when you opened fully, now A, B, C, D all are from Q. So this if you will open A plus B root 2 will go plus IC plus ID root 2. Same ABCD from Q. And in this case, over the field Q dimension will be 4. And basis set will be 1 root 2 I root 2. Here basis set will be 1 I root 2 and root 2. So here dimension is 4. Understood? Santosh?
Yes, sir. Yes, sir. Yes, sir. Understood, sir.
In your
So
notes,
we are
same I
writing,
did.
sir.
Ah.
Yeah, yes, sir. So, sir, can you see this, sir? This line. So Q of root 2 comma I means this one's dimension only, no, sir. The answer is. Or how we are calculating 2, sir, now?
Same question you are asking. Here you see. Q box root 2 comma I over the field Q box root 2 is 2. There I think over the field Q box I is there.
Yes, sir. Here
same you
Q of root 2 comma I.
Yeah, same you can choose for that also. Any one root you can take outside and over the field you can prepare. Same answer will come. You see, same things here I can do. Q box root 2 comma I. Here I choose I is outside. Over the field this I prepared. You want over the field Q box I in your notes. So I you keep inside and root 2 you take outside. Now your F is this. Over the field Q box I. So here also same, but now your this complete vector space will generate by root 2, means P plus Q root 2. And P and Q from Q box I. So same Q box root 2I over the field Q box I generating by 2 element, 1 and root 2. Here 1 comma I. Here basis set is 1 comma I. Here basis set is 1 comma root 2 over the field Q box I.
Yes, sir. Yes, sir.
So here dimension is 2 over the field this.
Yes, sir. Yes.
Again P and Q from Q box I. So P and Q plus you can write Q box I means A plus IB. And C plus ID. Here root 2 already have. Now ABCD from Q. So here in this case over means same Q box root 2 comma I over the field Q basis set will be 1 I root 2 and root 2. Same basis set.
Yes,
and
sir.
4
basis
dimension.
Set, 4 dimensions, sir. But can you see, sir? Can you see the note, sir? Now this step, how it is becoming? It should be 4 only, no, sir. Basic set. So dimension is 4 only, no. So how we are getting 2? I am asking.
Yeah,
in
Bhagwan.
That part
Your mind is here. That your answer only I am giving. What is over the for this over the field? What?
Over the field is Q of I, sir.
Then Q of I 2 only have no.
Yes, sir. Yes, sir.
And over the field Q writing means 4. Q box root 2 comma I over the field Q if you will write then 4. Q box root 2 comma I over the field Q box I if you will write then 2, or Q box root 2 comma I over the field Q box root 2 if you will write then 2.
Yes, sir. Yes, sir. Understood, sir. Now only understood.
Full history finishing also same type you are telling.
No, sir. Now, thank you so much, sir. I can't ask somebody, sir.
No problem.
Yes, sir.
Rain stopped, no? You have another day class. Otherwise, because of
yes,
you, I will
sir.
get wet maybe.
Yes, sir. Yes, sir. I'll copy, sir. So once again, sir. Sir, completed, sir.
Okay then. Again, another day hereafter.
Thank you so much, sir.
Always welcome.
Thank you. Really, yeah, sir. I think I have disturbed you a lot.
No problem, no problem. Doubts have tell me.
Yes, sir. Thank you so much, sir.
Thank you, welcome, no problem.